Hello everyone, I hope you are fine. Thank you for giving me the opportunity to talk about my intervention in the field of piezoelectric material. My intervention will be titled Piezoelectric and Electromechanical Coupling Coefficient in Half-Laser Compound LISRX, which X and IS and P based on a initial calculation. So I will start with a short review of the main title of my intervention, which will start a general introduction about the piezoelectricity and various applications. Then we will talk about the calculation method and the software used in this calculation. And we will review the obtained results of the structural, elastic, and piezoelectric properties, as well as the electromechanical coupling coefficient. Finally, we will conclude with conclusion for our calculation. Introduction. Today, piezoelectric materials are used in variety of applications, including motors, branches, micropositioning system, and ultrasonic transducer. As we know, silicon, titanium, and PZT are piezoelectric materials widely used in a large number of electronic devices to their excellent properties. However, the major drawback lies to the environmental and health problem associated with the presence of lead due to the high toxicity. That is why the scientific community has focused in the search of lead-free piezoelectric material. Now we will talk about calculation method and simulation tools. In our calculation, we used a Binet simulation program to calculate the structural, elastic, piezoelectric, and dielectric properties, starting from the quantum equation of the density functional theory. We can build up the advanced application with perturbation theory based on DFT and many-body green function. So, in order to analyze the result of this property, the NDDP tool are used to extract the dielectric, elastic, and piezoelectric tensor. So, for the crystal structure relaxation, the convergence has been reached with the energy tolerance 10-6 electron volt and with the energy cutoff equal 5T Hartree. In our investigation, the exchange correlation energy is adopted by the generalized gradient approximation GGA to study the ground state properties. And the iterative calculation process is repeated until the convergence of the total energy is stable at less than 0.1 millirad. For the preon zone, we used the mesh gradient of 14 multiply 14 multiply 14 K point for all components. The calculation of the elastic constant based in DFT was estimated by the second derivative of the total energy with respect to the atomic displacement, whereas the prediction of the piezoelectric coefficient of this compound were carried out using the modern theory of the polarization and density functional perturbation theory DFT based on the plane wave and the pseudopotential. In the framework of the modern theory of the polarization, the piezoelectric tensor are estimated by the second derivative of the total energy with the respect of the atomic displacement and electric field, whereas the dielectric parameter is calculated by the polarization induced by the strain. Now we have a detailed diagram of the calculation method used. Firstly, the three materials are selected, then a convergence test is performed for both the cutoff energy and the K point. Then we use the theoretical result as initial data for calculation the structure parameter such lattice, bulk and its derivative. Then we use DFPT to calculate the piezoelectric, dielectric, and elastic properties. So now we talk about the result and discussion. Firstly, we will talk about the structural properties. In order to predict the equilibrium lattice constant of Li-based half-acyclic compound, the structural properties of this compound were calculated by optimizing the total energy with respect to volume of the three possible atomic arrangements. The atomic position and the kpmg tape are not affected by the optimization because they are fixed by the high symmetry. So triple 2 present the calculated structural properties, the lattice parameter such as lattice constant, the bulk modulus, and its first derivative. So now we talk about the electronic bond structure and density of a state. So to study and understand the electronic state of our compound, we calculated the bond structure of LISRX along high symmetry direction in the barium zone. From the figure, it is observed the valence bond maximum of LISRN and LISRS compound lay to X point, whereas the conduction bond minimum lay to the gamma point, indicate that LISRX, LISRN, and LISRAS material are semiconductor with indirect band gap, but LISRP, the valence bond maximum and the conduction bond minimum lay to the gamma to the X point, indicate that LISRP has a direct band gap. So, to good and fully understand the electronic band structure of the half-acyclic alloy, the partial and total density of a set also presented. So, the plot are shown in this figure. The overall profit of K-dose and P-dose are similar for the three compound. Now we talk about the elastic and related parameter. As we know, the study of the elastic properties of material are necessary to know how hard, elastic, and mechanically stable this material. So the calculate of elastic constant of this compound are presented in the table, and the calculate value satisfy of the criteria mentioned that confirm that our compounds are mechanically stable. Piezoelectric and electromechanical coupling coefficient. In this section, we will also examine the possible piezoelectric effect in this compound using DFT and DFPT with GG approximation. Therefore, this calculation are definite the second derivative of the total energy with respect to the atomic displacement and the electric field. Among the 5 symmetric classes belong to the Capex system, only the crystal 43M and 23 are no centrosymmetric, and they are good candidate for the piezoelectric effect. The calculation of static dielectric tensor also presented. This result determines the figure conventional of the merit for piezoelectric K4T. We find that LISRS compounds are a good electromechanical coupling coefficient and can be candidate for the piezoelectric application as a guide for experimental investigation of piezoelectric half-acyclic compound. We highlight a selection of candidate compound chosen according to the relevant practical consideration. Thank you.